In this video, we're going to be discussing special quadrilateral properties. Now, in the past, we've discussed that quadrilateral means that we have a polygon that has 4 sides. Today, we're going to talk about special quadrilaterals. So you're going to be able to identify special quadrilaterals based on their properties, create special quadrilaterals using mathematical reasoning, and sketch and draw quadrilaterals accurately with appropriate marks, protractors, and rulers. The first special quadrilateral we're going to talk about is a parallelogram. A parallelogram is a quadrilateral with the following properties. It has the opposite sides parallel. It has opposite sides congruent. Opposite angles congruent. And it has consecutive angles that are supplementary. Remember, supplementary means that the two angles will sum to 180 degrees. So if we have a parallelogram, it must have those 4 properties. And there's ways to mark a parallelogram to show that they have these 4 properties. So if I were to sketch this parallelogram, the first property we said it had was opposite sides parallel. We've discussed how to mark parallel lines, and that's how we would mark it on the figure. The top and bottom would be parallel, so we would use one arrow on the top and bottom to show that they are parallel. They'll never intersect. And when I would have to use a different number of arrows, in this case I'll use 2, on the left and right sides of the parallelogram to show that they are parallel. So the left and right sides are parallel, and I marked them with 2 arrows each. And the top and bottom are parallel. I marked those with 1 arrow each. The next property, opposite sides are congruent. Remember, we mark sides that are congruent with tick marks. So I could put 1 tick mark on the top and bottom to show that they are congruent. And I can put 2 on the left and right side to show that those 2 sides are also congruent. Opposite angles congruent. Opposite, remember, they're like diagonal from each other. And another way to think is the 2 obtuse angles will be the same measure, and I can mark those with 1 arc. And the other 2 opposite angles, they will be the acute angles, are congruent, and I'll mark those with 2 arcs. The last property, consecutive angles are supplementary. There's not really a way to mark them on our diagram, but just know consecutive means next to each other. So any 2 angles that are right next to each other, whether, the top 2, the 2 on the left, the bottom 2, or the 2 on the right, when you add those angle measures together, you'll get 180 degrees. The reason you get that is because we have 2 angles on the same side between these parallel lines, no matter where you're looking. And we've already discussed those are consecutive interior angles, which is why they're supplementary. The next special quadrilateral that we're going to talk about is a rectangle. A rectangle is a quadrilateral with the following. It has all of the properties of a parallelogram, so all of the properties we just discussed, opposite sides parallel, opposite sides congruent, opposite angles congruent, consecutive or supplementary. But it gets more specific with the angles. So opposite angles are still going to be congruent, but more specifically, all of the angles are going to be 90 degrees. Okay. So we would sketch this rectangle The same way we did the parallelogram. I have to mark opposite sides parallel, do it the same way. One arrow on the top and bottom, and I'm going to put 2 arrows on each side on the left and right to show they're parallel. Opposite sides are still congruent, so the top and bottom, the left and right sides are still congruent. Opposite angles are technically still congruent, but it's more specific. All of the angles are congruent now. They're all 90 degrees, and we will mark them all as 90 degrees. And lastly, consecutive angles are still supplementary, and they're all 90. So no matter which ones I'm looking at, the left side, the top, the right, the bottom, 90 and 90 is always 180. The next type of special quadrilateral we're going to look at is a rhombus. A rhombus is a quadrilateral with the following properties. It also is a parallelogram, so it has all properties of a parallelogram. So again, we can draw our arrow going back to that first one. So it has opposite sides parallel, opposite sides congruent, opposite angles congruent, consecutive angles supplementary. But a rhombus gets more specific when it comes to side lengths. More specifically in a rhombus, all of the sides are congruent. So opposite sides are still congruent, like it is for a parallelogram, but it's more specific now that all sides are congruent. So if I were to sketch a rhombus, again, it has all of the properties of a parallelogram. Opposite sides parallel, top and bottom, left and right, and we're going to mark those. But now instead of opposite sides congruent, we're going to mark all sides congruent because that's what makes a rhombus different. So I'm going to put 1 tick mark on every single side of my rhombus to show every side is the same measure. I'm going back to parallelogram, opposite angles congruent. Same is true for a rhombus, so the 2 obtuse angles opposite of each other are congruent, and the 2 acute angles opposite of each other are congruent. Again, no way to mark it, but consecutive are still equal to 180 because we have 2 angles on the same side of a transversal in between parallel lines, so they'll always be supplementary. The next type of special quadrilateral we're going to look at is a square. So a square is a very special quadrilateral. So it's a quadrilateral with, and it has it all. It has all parallelogram properties. It has all rectangle properties. Remember, that just means 90-degree angles. That was what made rectangles different. And it has all of the rhombus properties. And we just discussed that that means all the sides were congruent. Okay. So if I'm drawing a square, we have to incorporate all of the properties we've discussed. So for parallelogram, opposite sides parallel. So top and bottom are parallel to the left and right. Now it has the properties of a rhombus. All sides congruent. So I'll put 1 tick mark on every side. Technically still opposite sides are congruent, still like a parallelogram, but this is more specific. And like a rectangle, all angles are congruent. They're all 90 degrees. So squares have it all. Okay? All the properties of parallelograms, rectangles, and rhombi. That was the last parallelogram we're going to discuss. The last three quadrilaterals we talk about are not, and I repeat, are not parallelograms. So they do not have the properties that we talked about for parallelograms. They have different properties. Kite is the next one we want to talk about. A kite is still a quadrilateral. And has the following properties. Two pairs of consecutive, congruent sides. So it has two pairs of consecutive congruent sides. Notice it didn't use opposite like we're used to. Consecutive means in a row. So two sides that are right next to each other that are congruent, two pairs of them. The second property is that it has exactly one pair of opposite angles congruent. So only one pair of opposite angles are congruent, and I'll show you in a sketch which ones they will be. So if I were to draw a kite, all right, we're just kind of sketching right now. The first property talks about two pairs of consecutive congruent sides. So the two shorter sides of the kite are going to be congruent, and they're right next to each other. The two longer sides of the kite are going to be congruent, and they're also right next to each other. Consecutive congruent sides. Now the second property says exactly one pair of opposite angles are congruent. The opposite angles that are congruent, they're always the two angles, they're directly opposite of each other, but they're the angles that are between the short and long sides. Okay, so you'll notice between this short and long side and between this short and long side, those are the sides that are opposite that are congruent. Okay. Trapezoid. A trapezoid is also a quadrilateral with the following properties. It has exactly one pair of parallel sides. So exactly one pair of parallel sides. And it has exactly two pairs of consecutive angles that are supplementary. So exactly one pair of parallel sides and exactly one pair of consecutive angles that are supplementary. So there's a couple ways you'll see a trapezoid. I'm just going to sketch, one example here. So if I have a trapezoid, exactly one pair of parallel sides. That means only one set of sides are parallel, not both. In this case, the one I drew, the top and bottom are going to be parallel. They'll never intersect. Now when it says exactly two pairs of consecutive angles supplementary, remember we've learned that property. When you have two angles on the same side of a line between parallel lines, that makes them supplementary, which means they add up to 180. So I could make up angle measures. I could say that this angle up here is 100 degrees, which means that this consecutive angle would have to be 80 to make 180 degrees. This one over here I could say is 130 degrees, which means this consecutive angle would have to be 50. 130 plus 50 is 180. An isosceles trapezoid. It is also a quadrilateral has all the properties of a trapezoid. So all of those properties, exactly one pair of parallel sides, exactly two pairs of consecutive angles that are supplementary. But it also has two additional properties. One, the non-parallel sides are congruent. And they are also called legs. So if I say the legs of the isosceles trapezoid, I am talking about the two sides that are not parallel to each other. And the other property an isosceles trapezoid has is that the base angles are going to be congruent to each other. Those are the top two angles and the bottom two angles. So if I'm sketching an isosceles trapezoid, it has the properties of a trapezoid. So one pair of sides parallel. In this case, it's the top and bottom. Non-parallel sides called legs are congruent. So these two non-parallel sides are the same. I put tick marks to show that. And base angles would be the same. Okay, so the bottom two, the two acute angles would be congruent, and the two obtuse angles would be congruent. So if the bottom two angles were 60 degrees, they're still supplementary with the consecutive angle. So this means these top two angles would have to be 120 degrees. The reason we did these notes, and the reason you're going to be using this in our project, is because the buildings you're designing are given descriptions using these shapes. For example, your hospital is a trapezoid, your grocery store is a kite, your school is a square, etc. So now I want to go through, make sure you have a protractor and a ruler with you. And I want you to if you don't, please quietly get up and get one. And we're going to practice drawing some of these figures. So the first figure we're going to draw is a rectangle with sides of 8 centimeters and 2.5 centimeters. Remember, rectangles have 90-degree angles, so we have to keep that in mind. And opposite sides are the same, so we have two sides that are 8 centimeters and two sides that are 2.5 centimeters. So I start off by using a ruler and drawing side that is 8 centimeters long. Move my paper up so you can see. So I drew 8 centimeters long, and I will label that 8 centimeters. The next thing I want to do is line up my protractor. And since all angles are 90, I have to do the same thing on both sides. I will put a mark at 90 when I line it up on the left side. And I will put a mark at 90 when I line it up on the right side. Now, since those have to be 2.5 centimeters in that direction, you line up your ruler so that the edge of your line and the mark you made for 90 degrees are right in line. And I'm going to go 2.5 centimeters in that direction. And I label that 2.5 centimeters. And I put my right angle. Now I'm going to repeat the process on the other side. So I'm going to take my ruler, and I will line up the edge of my line and line it up carefully with that tick mark that I made for the 90-degree angle. And I will draw a 2.5 centimeter line in that direction. So that's 2.5 centimeters. Now, if you drew these two sides and these two angles accurately, you can use a straight edge to connect these two sides to finish your rectangle. Now, a way to check to see if you drew it accurately, you can take your protractor, measure. So is the angle that I drew here on the top, does it turn out to be 90? Yes. The angle over here? Yes. I want to measure the top to make sure it's also 8 centimeters. Measuring, it is about 8 centimeters still. So that's how we draw a rectangle. Next, it asks us to sketch a parallelogram with sides of 5 centimeters and 9 centimeters and angles of 60 degrees and 120 degrees. Now remember, parallelograms have opposite sides congruent and opposite angles congruent. Okay, so 2 of the sides are 5, 2 are 9 centimeters, 2 angles are 60, 2 angles are 120. They're opposites. So I'll start this one off by using my ruler to draw a side that's 9 centimeters long. So I'm going to draw my side that's 9 centimeters long. It doesn't matter which side you put the 60-degree angle on and which side you put the 120-degree angle on. That doesn't matter. I'm going to line up my protractor at the end of my line. And on this left side here, I'm going to put a mark at my 60-degree angle to make it acute. And that means when I move my protractor to the other side, to the 120-degree angle, I'd have my obtuse. So over here it's going to be the 60-degree angle, and over here it's the 120-degree angle. Now it says these two sides are going to be 5 centimeters. So again, we line up our ruler with that tick mark we made, and take your time, you want to make sure it's accurate. And we're going to go 5 centimeters in that direction. 5 centimeters, and this was 60 degrees. So now we do the same thing. I line up my ruler with my tick mark that I made, and I go 5 centimeters in that direction. And that one was 120 degrees. We connect them. Oh, I connected them a little bit off up there. 9 centimeters. Opposite angles are congruent, so this angle should be 120. This angle should be 60. And again, if you want to check, line up your protractor. You can be within 1 degree. And if I line up my top, I look, it is 120, even though I didn't draw that angle. I drew the other ones accurately. If I bring it over here and line it up, you'll see, look, it's 60. So that's how you know you did it correctly. The next two so the first one is an isosceles trapezoid. Bases are 3.9 centimeters and 6 centimeters. And the legs are 3.1 centimeters. So bases are the top and bottom. The legs are the non-parallel sides that are congruent. We have 2 angles, 70 and 110. Remember, for isosceles trapezoids, the base angles are congruent. So I will start off by drawing a side that is 6 centimeters. Now the 2 base angles, I'm going to make them both 70 degrees. So I line up my protractor. I'll put a mark at 70. Remember, it has to be an acute angle. I'm going to do the same thing on this side, but I'll use the other 70 to make sure that side will also be an acute angle. The legs are 3.1 centimeters. So I'll line it up. I'll line up my ruler. All right, with that tick mark, I'm going to go 3.1 centimeters in that direction. So I go 3.1 centimeters in that direction. And that was a 70-degree angle. I'll do the same thing this way. So I line it up, and I will go 3.1 centimeters in that direction. If those are done accurately, you should be able to connect the top. And if you want to check, the top should be 3.9 centimeters. If I'm measuring, I'm getting about 3.9 centimeters. And if I measure these angles, they should be about 110 degrees. So if I'm looking and I lined it up, it's going to be about 110. If I line this one up, it's about 110. 110. The last shape we have to draw is a square. So we have to sketch a square. Remember, all sides of a square are the same and all angles are the same. So all the sides will be 7.8 centimeters and all the angles will be 90 degrees for a square. So I'm going to start off by drawing a side that's 7.8 centimeters. Now, if each angle is 90 degrees, you line it up on each side, similar like what we did for the rectangle. Put a mark at 90, and put a mark at 90. In that direction now, we will go 7.8 centimeters again. So I line up my ruler, and I'm going to go 7.8 centimeters in that direction. So 7.8 centimeters, right angle. And I'll do the same thing here. Line it up. And go 7.8 centimeters in that direction. Lastly, if you connect the top, if you want to check your work, the top should be about 7.8 centimeters, which it is. And the top two angles should be about 90 degrees, which they are. Okay. So this is good practice for when you start drawing your buildings for your island project. You have practice worksheets, and I will be able to help you tomorrow.